So hi everyone and welcome back to the HexCatFace channel. Today we'll be doing flat patterns by hand in Plasticity, and we'll be using the model that we modeled in the previous video in this series. So first of all, what sort of dimensions do we need when we're doing flat patterns? So here's a representation of a steel sheet that is being bent. So let's actually bend this. So when thinking about what happens in metals when you bend them, you can slice the profile into cross sections, and the cross sections that are closer to the inner surface are in compression, and the cross sections that are closer to the outer surface are in tension. And then there's a cross section that is unaffected between these, and this is the cross section that we care about. So this is the neutral axis. And there's a unit that we use to describe this neutral axis. So it's called the K factor. So the K factor is the dimension or the length from the inner surface to the neutral axis divided by the whole thickness. And this is dependent on what sort of bending are you doing. So is it air bending or is it coining, bottom bending, and on the materials and the radius that you're doing. So when we know the neutral axis, so the neutral axis is the thing that we are actually modeling as a flat geometry. So when modeling the neutral axis as flat, we can see that these dimensions, the leg lengths, stay the same. But what is changing here is the radius in the bend, or is the radius in the cross sections. So how do we get the radius, or the radius in the neutral axis? So we sum to the inner radius the K factor times the thickness to get this arc length, to get this radius here. And to model it flat, we need to make it as a line with the length of this arc length here. So arc length is quite easy to calculate. So it's just 2 pi r, and then as we're using a quarter of a circle, then it's just divided by 4. And if it's another angle, then it's just the ratio comes the angle divided by 360, and you times that with the 2 pi r. So I found this site sheetmetal.me that has general K factors for different sorts of materials and bending types. And how would you usually get it is by doing tests on a brake press. Well, this is a good starting point. So let's use this for the example that we're doing. So we're using stainless steel, and it's 2 millimeters thick, and the inner radius is 1 millimeters. So it's between 0 and the material thickness. So we'll be using 0.4 as our K factor. And now for the actual modeling. So let's duplicate a side here. I'll just do one of these sides to get so that you can get an idea of how to do these by hand. So here's the duplicate of the side, and we need to rotate this by 90 degrees. Then to get the neutral axis, what we do is we select these inner surfaces here. So this inner radius and this inner surface here. And we need to push these to the neutral axis. And we were using the K factor of 0.4. So let's start pushing these faces. So it's in the negative direction to push these towards the neutral axis. So we need to have the length be negative here. So let's put a -1 in the at the start, and then times then the K factor, then the material thickness. So times 2. And now this should be in the it should have pushed it in the correct direction. So 1.2. So that's correct. So it's less than than what it was. And now let's duplicate these faces. And don't select the inner radius here, so that we get 2 separate faces. If we were to select this one, it will make a connected steel sheet. But let's just copy these and then move them a bit. Now you need to rotate this face, get it flat, so 90 degrees. And then we need to place this edge on the on this edge on this edge on the other surface. And then we need to move this in the y direction here with the length of what the arc length is in the neutral axis. And how do we get that? So in plasticity, we can quite easily measure the arc length by just selecting an edge, and down here in the selection, it has this length, and when you click it, it will copy to your clipboard. So let's move this face by that amount. Then select these 2 faces to get a little bit of geometry between these. So let's make a loft between these, and put G0 to get flat geometry. Then extrude all of these. And 2 millimeters to get the thickness that we needed. And we can put this in a another folder to have them separate. So flat pattern side tap. Now you can remove what you don't need. So the surfaces here and the solid. So how about making the technical drawings then? Well, I've made a video showcasing how I make those technical drawings from Plasticity. So it's the CAD on Linux, my CAD for workflows on Linux. But yeah, thanks for watching.